Radiation. Some people get scared when they hear the word radiation, but is that really necessary? Well, I should say not always. That's because there are actually two main types of radiation, and not all of them are dangerous. The first set of types of main type of radiation, that's electromagnetic radiation. That consists of pure energy, nothing more. It has no mass. And the energy is divided in packages which we call photons. And they're traveling at the speed of light. Sorry for the misspelling. Photons is spelled PH, not an F. And the other main type of radiation is particle radiation. That consists of small particles, and these particles do have mass. And they're moving also at very high velocity. That's why it calls radiation. But its radiation is less than the speed of light. Let's talk about the first main type of radiation, the electromagnetic spectrum. That's all types of electromagnetic radiation combined. There are 7 different types of electromagnetic radiation, and no more. These 7 are all of them there are, and we apply them all. Everything in your daily life you can meet something that is either using EM radiation, the part of type of radiation from the EM spectrum, or it has been used for it. There's also different levels of danger for it. First of all, we have radio waves. Radio waves, you might already guess the application to radio, but also television signals are being sent by that, and portable radios like that one over there. Penetration. How deep can you get with radio waves? You might think it's high because it gets quite a long way in the air, but when there's materials in between, it won't get that far. Like that walkie-talkie you see there, in an open field its range is a couple of kilometers, but inside a building it's only a few meters. So penetration is low, and the danger non-existent. No danger to your health on radio waves. Microwaves, you might already hear something in the name for that. It's applied in microwaves, of course, microwave ovens, but these were derived from radar installations. But also your Wi-Fi router at home and your mobile phone also use microwaves. Penetration low. Think about the range that your router can find your signal. So it's low. Danger to your health non-existent. This will do absolutely no harm to your body, nothing whatsoever. Infrared. Yep, that's also there. We use it in heat cameras, but also in remote controls, and we now have infrared ovens. Penetration low, danger non-existent. Well, unless you crawl into that infrared oven, but otherwise, well, see if you fit in there. But no danger to your health. Next step is visible light. Yeah, come on, you heard of that. And you know how that's applied. In torches and in cameras and your own eyes, of course. That's why it's called visible light. Penetration, well, put a sheet of paper between you and this monitor, and you won't see the monitor anymore. Penetration is low, and still no danger to your health. Would be something if just watching around you is a danger to your health. No way. But then, infrared means less than red. The next one, ultraviolet, means more than violet. These are, of course, the both ends of the visible light spectrum, or the rainbow. What is ultraviolet used for? Well, for money detection, whether it's real or not. Well, the solar banks and blacklight. Penetration, well, the previous 4 will not go through the outer skin of your body. This will. average penetration depth. And that also means there is some risk with this. That's why if you go out into the sun, you have to put some sunscreen on. Otherwise, well, skin cancer is a result of ultraviolet light. So I guess you already know we go further. Energy, X-rays. These are used for, of course, X-ray photos, but also at the airport where your luggage control, and to study the different layers of paint in paintings. Penetration is high because it can get through the whole of your body. And, well, you might already guess, there's quite a bit of danger on that. This is no toy. Do not play with X-rays because it can be really dangerous to your health and can cause cancer all through your body. And even more with gamma rays, used in different types of situations, like in cancer treatment, like in food conservation. That's the word I was looking for. And astronomy, as also in diagnosis in hospitals. Why food conservation and cancer treatment? It can cause cancer, but can also cure it. Why? Because gamma rays have the possibility of going through your body, of course, but also of killing cells. Now, if you kill the wrong cells that shouldn't be in your body, you're happy. If it kills cells that should be in your body, you're not so happy. Now, if it kills a few cells in you, well, you won't notice very much. But if, say, you're bacteria, if you have only one cell and that cell is killed, well, then you're not there anymore. And that's why it's used for food conservation. It kills viruses and bacteria. Penetration is very high. Danger is quite a bit. Do not play with gamma rays. And that's everything there is about the electromagnetic spectrum. The other main type was particle radiation. Particle radiation, there's lots and lots and lots and lots of sorts of it. We will not discuss them all. Just the 5 most abundant versions, types of particle radiation. And the first is alpha radiation. Each type of particle radiation is by moving fast-moving sorts of one certain particle, and alpha is the nucleus of helium-4 atoms. That's a helium atom without its electrons. Penetration depth is very low. It will not get very far. You can even screen it off with just one sheet of paper or 30 centimeters of air. However, this is really dangerous. Not if you get it from the outside, then there's no problem. But when you get it inside, oh dear. That's why danger, alpha radiators, panic. Next type is beta minus radiation that consists of electrons. Average penetration depth will get some few centimeters into your body, but it will cause some danger, some damage there, so not good for your health. In fact, I have to note to mark that all types of particle radiation are dangerous for your health. Also, the beta plus variety, a very special type, because it's made up of particles that not really come through. You get through about every day. Positrons, positive electrons, and this is an example of antimatter, normally not present on Earth, but unless it is emitted by a beta plus radiator. We'll get through that in another video. Penetration average, because it has all the same capabilities as beta minus radiation, and so its danger is also comparable. You won't get happy about it. Proton radiation, that's what P radiation stands for. Protons lose protons at high speed. Don't stand in a proton ray. That is not very good for you. Average penetration depth, just like the previous two, but larger particles, more damage. If you are a healthy person and you get hit by a proton beam, start crying if you still can. And the last in the series, that is a really nasty one. The neutron radiation consists of neutrons, a very high penetration depth. It's actually not causing any damage itself, but the really tricky part is that neutron radiation will not cause any damage itself, but it changes atoms in your body into radioactive atoms, so you will be radiated from the inside. Not a nice thing to happen. Well, that's all you need to know about radiation. So, are you scared of radiation? Well, not if it's one of the first four of the electromagnetic spectrum. That's no danger at all. But the others, avoid them if you can.